Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
This is Jeff Carpenter and Nick Panahi. We are coming at you from an undisclosed location somewhere in North America. Okay, it's DataStax headquarters. For this week's episode of the Distributed Data Show, we're talking with Nick about search. Now, we've had Nick on before.
Hello.
But I will have you kind of reintroduce yourself. Not only are you the product owner for search, you are also a guy who has used this stuff in the real world before. So anyway, just catch us up real quick.
Absolutely, yeah, real quickly. I came from a customer. We were using DataStax Enterprise there, building something very similar that we had read from the internet around what Netflix was doing. So we had a very similar use case there. The unique journey for us was that we were using search in a non-searchy way. So we can get into some of those details about
off-label prescription, yeah.
That's right, exactly. Relational Band-Aid is kind of what we talk about as an anti-pattern there. But I came to DataStax as a solution architect for a couple of years, and through bloody knuckles, as my boss likes to say, we got plucked from the field and have an opportunity to lead the product or products, and it's been an absolute blessing, and it's been a lot of fun, and I hope I've been making a difference, of course.
Okay, well, we'll be the judge of that. I mean, we're gonna do our best to test your knowledge and ability to communicate what is going on with DSE Search in our new release, DSE 6. So we're obviously super excited. Again, our biggest release ever. We tend to say that, but definitely a lot of major strides forward in this release across the board, and we're going to reference some of the things that are even outside of your product area because it's all so very integrated together. But specifically in search, what is driving DSE Search forward in the 6 release?
Awesome. Yes, I'm very excited about this release from a product perspective, from a search perspective. The biggest things for search in 6.0 is going to be that integration with our advanced performance mechanisms, as we call that, the TPC stuff.
Okay.
The other part of it is another ease of use aspect of API story and queryability.
Right.
In a couple of ways there. So those are very exciting things, and we'll share the details there and what that means and where we're going with that stuff in the future.
Okay.
So starting with, I guess we can start then. Starting with the API story, like we talked about, the initiative or the theme that we kind of focused here was search-enabled SQL. So what that is basically a recognition that SOLR syntax is not intuitive. It's not easy. We don't come across a lot of SOLR experts in the field in general, let alone our customers. And watching that pain of how to figure out how to do some search queries, or even how to leverage a search engine for indexing, has created an opportunity to fix some of these problems. So what we're driving at is basically we want to collapse our API story down to SQL. We want to leverage the native protocol there, but also we want to eliminate that curve of learning for the syntax. So borrowing as much as we can from SQL. Yes, I did say SQL.
It's not a dirty word.
It's not a dirty word. I agree.
Right.
There's a lot of cues there we can take because, as you can see, some of those systems include text search as well these days.
Right.
So outside of indexing, there's some cues to take there. As well as, as we're familiar with SQL being a very quick and lookup language, there are also some simpler things we can do, like Boolean queries and such like that. So
okay, so I want to dive into some of this, but
Great.
Just to level set for some people that may or may not be familiar with what it looks like right now to use DSE Search. If you're writing a SQL query, you end up with these clauses that are in there, like a where SOLR query equals, right? And it looks like SOLR query is a column, but it's not really a column.
That's right.
We're intercepting that and then interpreting the contents, and then so I can understand why we have that, and that makes total sense. I also, as a major step forward, integrating more and more so it looks natural, just like regular SQL. So I mean, can you talk about some of the implications of this because this allows you to include columns in your queries that maybe you really can't in regular SQL. Is that right?
That's exactly right. That is the purpose. If we look at a little bit from the implementation level, it is analyzing what query is being passed in from a pure SQL syntax and understanding if because I have indexes in the background, could I actually go ahead and hijack this query and execute it against DSE Search? So a SQL query comes in, we know there's a lot of restrictions there.
Right.
If you happen to have search enabled and things indexed, which a lot of our customers do, then a query that would have previously just failed because Cassandra says, hey, this is not part of the key story. We can't do things
You can't
here.
index on it because it's not a part of your primary key. Right?
Exactly. And this inspector will basically say, well, I've got DSE Search enabled. I've got indexes here. I actually can run this query. So I'm going to go ahead and do that for you. So the implications would be a couple one good, one potentially bad. The good is that queries execute. That would have failed.
Right.
But the other part of it is now you have to be a little bit more conscious about SLAs in the sense of.
Okay, I was going to ask you.
Yes, of course. I'll be honest. SQL
Yeah.
is great for these very low latency lookups, and then we still want to maintain a lot of that. So there's going to be a little bit of thought about, am I leveraging my search index as part of this query or not? And whether you really want to or not for some of these use cases.
Now, can you look at tracing information, or what ways do we have that you could actually get a sense of when you might unintentionally be using a search index that maybe a developer that is not aware maybe didn't intend to use?
You basically said it exactly right. Our tracing mechanism. The more we advance and the more we integrate, it is going to go back to those tools that are available from the core technology for troubleshooting, for monitoring, for configuration, whatever that may be. So tracing is the answer to kind of inspect that query's path, basically.
Okay, that makes sense. Okay, so we talked about you can now query on columns that maybe you wouldn't have been able to in a regular SQL query. What about other syntax? Like you mentioned text search a minute ago, so
that's right.
I know that we're doing some things, introducing some new keywords into SQL, right? So what's happening there?
Yeah, that's a great segue. Thank you. And I think last time we spoke, we did touch on some of the SASI index, basically. So this new index that came out that did attempt to provide some text search, and with that came a keyword, the like keyword.
Which is that's the initial appearance of like. That's right.
Very
with SASI, right?
Very familiar to SQL users out there. Very powerful for, of course, it doesn't have to be a search engine search, but substring text, prefix, postfix kind of stuff. And I'm happy to say that while DataStax Enterprise hasn't blessed the usage of that, we talked about that last time, the SASI. We can offer that today with DSE Search. So like queries are now possible through DSE because of this mechanism, and just acknowledging the fact that some certain keywords will now work, and the functionality is in line with what it's supposed to do is from a functional perspective.
Right.
And we have it. So we have the like keyword. That's really the highlight of the newness of the syntax.
Okay.
But of course, some of the other is not null, contains, in clause type keywords will certainly also work, going back to our original point of things that will run that previously wouldn't.
Okay. Excellent. All right. So, are you able to talk a little bit about what's going on behind the scenes? Now, you mentioned before some of the advanced performance characteristics that are in the core, just the standard, Apache Cassandra-based database, like the thread per core. So, what is the under the hood benefit of what's going on?
So I love this question because for a couple reasons, we benefited in a lot of fortuitous ways that we didn't expect with this integration. Okay. And to kind of really showcase the value, I guess we do have to touch a little bit on how things used to work. We don't have to go completely in depth, but let's just talk about this indexing pipeline. This is really where a lot of this newness came from that we like to talk about. So.
Tell me about an indexing pipeline.
I would love to talk about our indexing pipeline and the changes that came. So if our users are familiar with DSE Search from the past, let's just say we know that this is a SOLR and Cassandra integration. We have integrated the right paths, basically. So you write into your database system.
Yep.
Database will take it and index it for search, and that's the whole point of it. Now, if you take a magnifying to this process, pre-6.0, what we didn't see were some of those internal workings. We had a basically asynchronous match up here with this indexing and writing. So initially that sounds the right path. We have a very high throughput ingest system. We don't want to bog it down with back-end kind of activity. Asynchronous usually is our first attempt to kind of keep things flowing from each other. So with that implementation, there was things like backpressure, indexing queues. There was configuration that you had to observe and do to just how big is a queue, how many threads should I have to process on this queue, and things like that. One of the unfortunate pieces of the old architecture was when you from a driver perspective, in a developer relations way, when you write to your database and you get that acknowledgement back for your client, traditional users expect that this is my atomic operation, things have gone all the way through and flowed, and I'm good to go.
Right.
This was not the case with our asynchronous matchup. Your acknowledgement that came back was really about, hey, Cassandra's got it, but the indexing still had to kind of happen in the background.
And the index will catch up at some future point.
It will. Yep.
Not that it's going to be that long.
No, it's not that long.
How
but,
long are we talking about?
You know, if we go into, it's subjective, but let's say 10 seconds because that's a default commit time configuration that we see. So that doesn't mean it takes that long for it to be indexed. It means that there's this concept of visibility with search engines and search indexes. So, you know, we're 10 seconds by default. So you do a write, you will have to wait that 10 seconds before acknowledging this thing. But the bigger problem to me it wasn't the latency, it was really the visibility. How does a user know that this got dropped, that backpressure was applying, that my write did go all the way to my index, and I can do a search at some point? So that was the bigger problem in my mind.
Right. Okay, and feedback to the application that
to the users,
what they can expect. Right.
Exactly. Yeah. That's very important for our distributed system because we talk about retries a lot. We don't talk. We talk a lot about item potency,
yes,
and data models and retries if things fail, and add once delivery and at least once delivery, things like that. So that was really the bigger issue to me versus the latency of the sync up.
Okay.
So with our new and improved TPC integration, what's been awesome about it is we've completely been able to flatten this pipeline. Not only flatten it to where your write goes to the database, indexes that row, places it directly on this piece of memory, the RAM buffer, if you will, get specific with it. That's where your acknowledgement comes back now. So that's a lot cleaner of an approach for the developer. You know at the very least that your data got indexed and has been placed and is ready for commits. And if something happens along those lines, then a retry now really benefits the entire system. So it's not fully synchronous, but it's a lot more than it's ever been, and the operations are a lot more atomic than they've ever been as well. So this is one of those fortuitous things that we didn't realize we were going to get from that. Along with that means a whole host of configuration knobs go out the window, which is great.
Right. Okay, so I'm not worried about backpressure.
No more backpressure.
Number of threads.
Exactly. Okay. You configure TPC, and you are basically done. So all of this queue size, indexing, thread pools, all gone, which is a big win for ease of use. But it's not just making it easier to use, but there's legitimate benefits from a integration standpoint from that as well. Like I said, so we're just getting closer to this atomic index creation story that we've observed our users really need and want. Now, there's that missing piece about that 10-second soft commit thing we talked about, right? The other piece of how we can kind of help this is with our real-time indexing functionality. That is a DataStax Enterprise specific thing. And what that is basically a higher throughput and reduced visibility on this RAM buffer. So we just take our queues from Cassandra, we turn this piece of RAM into a mem table, just like Cassandra works. So we can search on this thing, and our viewing refreshing is much faster, let's say 100 milliseconds. So if you combine a synchronous write to this buffer and a 100 millisecond commit, you are now even closer to the synchronous operation and atomic operation for indexes, which of course not only gives you text search, but just traditional indexing, Boolean queries, more flexibility for your queries.
Okay. So is that memory set aside for search, that memory buffer, is that a separately configurable? Is that a new configuration parameter? Now then I'm now configuring the size of that?
Great question. The answer is it's not a new configuration. Another really cool benefit was traditionally with every search index you create, you will have, so this piece of memory is called the RAM buffer. This is where index data lives until you can search on it. Every index that you had on a table had its own RAM buffer. And that sounds good, but really we're talking about hogging up more memory in the JVM.
Yeah.
And certainly the more indexes you have and the bigger this thing gets, the more you're eating away from that and creating pressure. And that can be a problem at times. So another great thing that we've noticed from our testing and what we were able to do is we have a global RAM buffer now for all indexes.
Okay.
And so the configuration becomes easier again,
right?
Because you just have one value to set. And from our testing, again, default is working really well. So it's almost another configuration thing that you just don't even have to worry about again. But reduced memory footprint as well, which is always going to be a nice benefit for applications.
Okay.
So that is the other added bonus of this integration.
So we talked a little bit about some of the performance improvements that you've seen for different cases, like how quickly the index updates are actually reflected in a way that you could access on your queries. What about just lookups? Do you have any data on the performance based on the new implementation?
Absolutely, and there's something to be very clear about here with regards to query latency. Because of the redesign we talked about and the longer prolonged write, yes, of course the latency for a write is going to be more because it's not an apples to apples kind of comparison. Previously, we'd have to look at the commit from Cassandra, and then we have to go analyze how long things go from that indexing queue then down to the index. Add those together, and that's your real query latency. I mean, your indexing latency for that write.
Okay.
So all I'm basically saying is, yes, the latency for that one write grows, but that's because of a redesign. The throughput is much higher. So that's really the benefit. So the throughput being higher means obviously you can get more queries per second. As well as, if we go back to kind of this synchronous kind of aspect of things, stability. Huge amount of stability gained from, while it sounds funny, removing a backpressure mechanism gives you stability. Again, just having that thread do all the housekeeping, we just see far more stability in the sense of drop mutations.
Fewer moving parts, right?
Yes, yeah, exactly.
That makes perfect sense.
So the drop mutation story is really nice as well, because that just means more consistency across the board, data store and index.
Okay. Now, is there anything more that you want to share about what's going on with search in DSE 6? And yes, I'll stop there. You should just go with it.
Well, I'll say yes. And really what I want to share here more is kind of touching on more of what we've already talked about, but kind of giving some insight. You know, the search enabled SQL was really the first step of a long process. So a lot of behind the scenes work was done there to be able to look at the query, inspect it, and execute it.
Right.
This starts opening the door to a conversation about query optimizers and picking the best path for your query, not just for search, but any index we come up with in general. And then the other piece of that is you're going to see SQL expand more keywords and more functionality natively, right? We know a lot of our users are very interested in geospatial operations, so we'll see this in SQL one day, very soon. Relevancy scores, things like that, searches. All of these, again, taking cues from SQL and adding this to our story. So it's really about kind of giving insight to, we did a lot of internal work today to make this happen.
That really has set us up,
for some great functionality and seamless integration later that will be certainly leveraged by all the pieces of the system. And then little things come out of that, right? We get prepared statements finally for search queries, and we get better studio support because it's just native SQL. You don't have to add these special hooks to say this is SOLR syntax or whatever.
It just comes along for free.
It comes along for free. So it really plays well to our unified platform story and making things a lot more visible as far as what's going on where.
Good. Okay, so I asked you half a question and then I let you go, and the other half of the question was going to be basically like, what does this set us up for in terms of possibilities for, you know, like a DSE 7 release? So I think you've already kind of given us some major clues about that. And that's really exciting. You and I have talked before. You know that geospatial queries that was always one of my pet peeves, I should say, or I don't know, rough edges in my past job, where I really wanted to be able to do queries like that, and that was always a hard thing to figure out how to accomplish, right, with just raw basic Cassandra. So
certainly,
I'm happy to hear for any better support for that, because you know there's some use cases where that is definitely anything that's map based or geospatial based is going to be able to make usage of that. So
you know, if you think about our distributed story as far as not the show, of course the show is distributed, but our database and our story about data autonomy and high availability, user experience often needs this component now because, you know, if you're asking for a restaurant, obviously, like you should know where you are. I'm not going to show you a restaurant in Atlanta if I'm out in San Jose for the week.
Right.
Little things. I remember Intuit Mint app, one of the first things it asked me was, hey, where are you located? For a better experience, type in your zip code.
Right.
And it just seems that the more we move toward cloud applications and cloud architectures and distributed globally, this becomes less of a nice to have and more of a I have to have kind of functionality. to drive context. So certainly to your point of geospatial desires, I'm really excited about that aspect of things.
Cool. So, I mean, we have had DSE 6 has been out for, early preview release to some customers that have been out there kicking the tires on it. Yeah. So what are you hearing?
Unbeknownst to me, a surprise was, of course, the number one interested feature was thread per core, our new architecture.
Yep.
Number two, and as of lately tied with number one, has been search-enabled SQL.
Okay.
Did not think of that to be that desired, again, because most of the work was behind the scenes.
Right.
We've really only exposed a little bit of new functionality there. But hey, the market wants what the market wants, and this seems to be a very desired thing, which again kind of validates the fact that SOLR syntax can be very tough, and queryability and Cassandra could benefit from a little love there as far as flexibility goes.
And actually, I'm not surprised to hear that, and maybe you were surprised, but in terms of impact to the developer, I mean, something that's going on under the covers like thread per core, like a re-architecting of the some of the core guts of Cassandra behind the scenes, is not necessarily something that a developer is going to see, except for in terms of obviously improved performance, right? Faster reads and writes, but in terms of some of the impacts, the way I write programs, the way I write my application, that search-enabled CQL is a big deal.
Awesome.
It is going to simplify a lot of things, and it's going to open up a lot of queries that previously weren't possible or weren't very easy to write.
Right.
So,
right. Exactly. So I love hearing that as well. It was a big aha moment for me, or eye-opening moment, and that just shows that we're on the right path, and that's always exciting. That's always exciting. The last thing I'll bring up, and this is really more of a teaser than it is kind of what's new, is
we allow that.
Great, yeah. I love that, because that just means you'll invite me back and I'll get to talk more about things. We talk a lot about search, indexing, indexes in general. I do want to put out there that this is something that we not only have noticed is of value to our customers. Having again, the queryability is a big story here.
Yeah.
And it doesn't stop with the API, but providing good indexes or more native database indexes is also an initiative where we're not blind to. So not everybody has a search engine use case, but far more people are utilizing the search engine for basic indexing than we probably would be comfortable with. But acknowledging this, embracing it, and building mechanisms to further make this use case successful is basically a lot of our initiative as well going forward.
So what's an example of that? Somebody using it for basic indexing?
So this happens, again, my entire career was, I just want to be able to do a query on another column, and I don't want to build another table for it. And this was before materialized views, when we only basically had secondary indexes, and that visceral pain of just saying, well, I'm sorry, you're going to have to build another table.
Right, okay.
So they'll say, well, you have SOLR here, so can I just throw
turn that
search
on.
index and do that? So, well, you can, but this, that, and the other.
Here's the trade-offs.
There's the trade-offs, and they're like, well, we don't care because we want to do this. So fighting it in the field for a couple of years was what I was doing.
I see.
And then kind of leading the product was like, you know what? We can't fight this. We need to embrace it and make this story better. So let's say indexing along with search indexing are big initiatives for us, and you'll see a lot more of that coming as well.
Okay. Yeah, and that makes total sense because I've been there, right? I mean, application developers, many of those who are listening will be able to relate to this. We always say in Cassandra data modeling, you want to create tables around your queries, anticipate what all your queries are going to be, design tables for those. We all know that it happens that you make changes to your application design after the system is in production. You come up with a new feature and a new query pattern.
Yes,
right? So
almost inevitably.
So there has to be a good answer for it.
That's right.
And I'm glad that you're working on it.
Thank you very much. I'm very excited about that as well. That's been a long-deserved feature for our users, and I'm happy we're moving on initiatives to actually provide those.
Excellent. Right. Well, it's been great to have you on again. And yes, thank you for the teaser. We will have you back on again.
My pleasure. Thank you so much for having me. I always enjoy this. So looking forward to seeing you again.
Okay. Until next time. Thank you, everyone.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, Make sure and subscribe so you don't miss a single episode.